Good evening all of you. So in continuation to the previous class, let us prove another vector identity, that is fourth identity. Prove that del cross A bar. So del cross A bar is equal del of del dot A bar minus del square A bar. That we have to prove, right? So in this, A bar is a vector. For that vector, if you have to find del cross, and again for that vector, del cross of A bar is again a vector. For that vector, again you have to find del cross. So del cross nothing but curl. So curl of A bar. So curl A bar. C-U-R-L, curl. Curl of A bar is equal to grad of div A bar minus del square A bar. In other words, we can say this identity like that. Curl A bar is equal to grad of div A bar minus del square A bar. That we have to prove. So let us start with LHS. So what is that LHS? Del cross A bar. Started with LHS. Just maintain brackets. According to definition of del cross, nothing but curl. Apply that notation. What we have? Del cross of that. Sigma I bar cross dou by dou x of sigma I bar cross dou by dou x of that part, that is del cross A bar. Now we have sigma I bar cross dou by dou x of del cross A bar. Now I have to write about this part, del cross A bar. So take this part separately, sigma of something, let it be 1, LHS we have. Except sigma, take the remaining part. What we will get? I bar cross dou by dou x of del cross A bar. Taken this part separately. So I bar cross as it is, dou by dou x as it is, del cross A bar. For that you have to apply the definition again, sigma I bar cross dou A bar by dou x. This is the definition of this del cross A bar, just like this. Now that is equal I bar cross dou by dou x as it is, sigma, expand that sigma expansion. So I bar cross dou A bar by dou x plus, you know that sigma expansion, replace I bar by J bar and x by y. What you will get? J bar cross dou A bar by dou y plus K bar cross dou A bar by dou z. This is the sigma expansion. Sigma I bar cross dou A bar by dou x. That first term will be as it is, plus replace I by j and then j by k, replace x by y and then y by z. So we will get 3 terms in that expansion of sigma. Now coming to this, I bar cross dou by dou x of these 3 terms. So apply dou by dou x to inside. That will be I bar cross dou by dou x of A bar will be dou square A bar by dou x square. Dou by dou x, dou square by dou x square of A bar plus J bar cross dou by dou x of that part, dou by dou x of dou by dou y. So dou square by dou x dou y of A bar, here A bar we have, plus K bar cross dou by dou x of that last part, dou square by dou x dou z of A bar. I bar cross dou by dou x of this first term, dou by dou x of second term, dou by dou x of third term. So I bar cross as it is, dou by dou x of A bar, 2 times dou by dou x, dou square by dou x square of A bar. J bar cross as it is, dou by dou x of dou by dou y. So dou square by dou x dou y of A bar, and K bar cross dou square by dou x dou z of A bar. Now I bar cross this first term, I bar cross second term, I bar cross third term. Just separate I bar cross to each and every term. So I bar cross dou square A bar by dou x square. Maintain bracket. For that This is first term plus again I bar cross j bar cross dou square a bar by dou x dou y, maintain brackets for the second term, plus I bar cross k bar cross dou square a bar by dou x dou z, dou x dou z, maintain bracket for this and for the entire one. So what we are doing here, just separating I bar cross to this term and this term. Now again vector triple products, first vector, second vector, third vector, three vectors in product, three vectors in product and three vectors in product. So you know that how to expand the triple product of a vectors. Write that I bar dot dou square a bar by dou x square into I bar, this dot this into I bar, minus I bar dot I bar will be 1 only because they are unit vectors. Mod I bar square will be 1. And here it is dou square a bar by dou x square. Dou square a bar by dou x square. This expansion. Plus I bar dot dou square a bar by dou x dou y. I bar dot into j bar minus I bar dot j bar will be 0 because they are mutually perpendicular unit vectors. So if you find the dot product between two mutually perpendicular unit vectors, you will get 0. So I bar dot j bar 0. No need to write the second term. Coming to third term, I bar dot dou square a bar by dou x dou z into k bar minus again I bar dot k bar, but I bar dot k bar is again 0. So 0 into that part, we can leave that term. So what we have, I bar dot dou square a bar by dou x square into I bar minus dou square a bar by dou x square plus I bar dot dou square a bar by dou x dou y into j bar plus I bar dot dou square a bar by dou x dou z into k bar. So these are the terms we have. So it is k bar. Now what is this value? I bar cross dou by dou x of del cross a bar. This is in equation 1. For that you have to apply sigma. So sigma notation. Coming to that part. Therefore sigma I bar cross dou by dou x of del cross a bar, that we have to consider. So sigma I bar cross dou by dou x of del cross a bar, I am taking that, is equal to applying sigma to each and every term. Applying sigma to each and every term. So here sigma I bar, I will write this I bar first, and I will take dou by dou x also outside. So I bar into dou by dou x of, what's remaining? I bar dot dou a bar by dou x. That is the bracket part. This term. Plus, coming to this term, applying sigma again, writing j bar. You can write sigma as a whole. No need to write here again sigma. Now what about this? J bar into dou by dou x of, that will be I bar dot dou a bar by dou x, dou y. Taken dou x outside, remaining dou y. Plus, coming to the third one, k bar here, dou by dou x outside. Here it is dou by dou x 2 times. Here dou by dou x, dou by dou y. And I will write here dou by dou x first. Just a minute. So here it is. I will write this step again. Now see here. So applying sigma and writing this first term, third term and fourth term, all in a grouping, and this term at last. Now coming to this, sigma I bar dou by dou x, taken one dou by dou x outside, remaining I bar dot dou a bar by dou x. I bar dot dou a bar by dou x. What about the second one? Plus, here j bar. Here we have dou square by dou x dou y. Dou square by dou x dou y. Write dou by dou y outside, and inside I bar dot dou a bar by dou x. Plus, Coming to last term, k bar, dou by dou z outside, remaining I bar dot dou a bar by dou x. First term, third term, fourth term. From first to third and fourth, taken I bar into dou by dou x common, j bar into dou by dou y common, and k bar into dou by dou z common. See the brackets. I bar dot dou a bar by dou x, I bar dot dou a bar by dou x, I bar dot dou a bar by dou x everywhere. And one more term remaining, this second term. Applying sigma for that also, dou square a by dou x square. So just applying sigma and writing the terms in order, we are getting this. Now see this part. Sigma I bar dou by dou x of something plus j bar dou by dou y of something plus k bar dou by dou z of something. That something part is common to everyone, everywhere. I bar dou a bar by dou x, I bar dot dou a bar by dou x, I bar dot dou a bar by dou x. That I bar dot dou a bar by dou x, you can write it as, now outside part, I dou by dou x, j dou by dou y, k dou by dou z. That is nothing but del of, that bracket part will be nothing but del dot a bar plus, and coming to that last term, here it is dou square a by dou x square. If we expand that sigma, dou square a by dou x square plus dou square a by dou y square plus dou square a by dou z square. Three terms we will get. So that is nothing but dou square by dou x square and dou square by dou y square, dou square by dou z square, nothing but del square. So that will be del square, and a square taken outside, that will be a square only. So this is your RHS. That only we have to prove. So del of del dot a bar minus del square a bar. See that? Curl of a bar. This is curl and this is curl. Curl a bar is equal grad of div a bar minus del square a bar. So taken that LHS part, applying sigma notation using the definition of curl. So del cross something, sigma I bar cross something dou by dou x of that something part. Sigma of something, let it be 1. Now take the part after sigma. So taking that I bar cross dou by dou x of that del cross a bar. Again applying the definition of curl, sigma I bar cross dou a bar by dou x. I bar cross dou by dou x as it is. Now expand that sigma, we will get 3 terms. Now expand this I bar cross dou by dou x to each and every term. We will get this I bar cross dou by dou x of this, I bar cross dou by dou x of this, I bar cross dou by dou x of this. We will get 3 terms. And I bar cross of that, I bar cross of this, and I bar cross of this. After that, applying triple product formula, I bar dot this of this minus I bar dot this, I bar dot I bar of this. That will be 1. That's why only one term will be here. And here coming to triple products, I bar dot that last term into middle term minus I bar dot j bar you have to write actually, but that will be 0. That's why discarded. And here I bar dot dou a bar by dou square a by dou x dou z, that one here into k bar, but I bar dot k bar will be again 0. That's why discarded. Coming to, this is the value for this term. For that you have to apply sigma. That's why taking sigma on left side and applying sigma to each and every term, we will get like this term. Sigma I bar into dou by dou x, taken one dou by dou x outside. So I bar dou by dou x of I bar dot dou a bar by dou x and j bar dou by dou y of I bar dot dou a bar by dou x and I bar dot dou a bar by dou x. So this I bar dou by dou x, j bar dou by dou y, k bar dou by dou z, nothing but del of del dot a bar. You can write that in that notation. And coming to the last term, dou square a bar by dou x square. So if you expand that sigma, dou square a bar by dou x square plus dou square a bar by dou y square plus dou square a bar by dou z square. Taken a bar outside. Sigma dou square by dou x square, nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Nothing but del square. So del of del dot a bar minus del square a bar. That only we have to prove. That is grad of div a bar minus del square a bar. That is the curl a bar. That is del cross a bar. That is the identity. Right? This is the fourth identity in continuation to the previous classes. Right? So thank you very much. Thank you all.